Hey, Carter, how's it going?
Going wonderful. Thank you.
Good. Yeah, pleasure to have you on today. Thanks so much for taking the time. It's great to have you guys over from Phoenix on here. I know we have, our teams had connected recently, and then we found out we had many different connections together. So it's a pleasure to have you here today to talk a little bit further. I'll just introduce myself and Range, and then I want to give the reins over to you. So I'm Paula Petit. I'm the VP of Strategy and Growth here at Range. We host these fireside stablecoin sessions to talk with different leaders in the stablecoin and digital asset space to learn more and give the space a spotlight. And at Range, we are essentially building stablecoin infrastructure for payments and digital asset treasuries. So we work with many teams like Circle, Stellar, Solana to monitor their assets across chains, assess transaction risks, and enforce treasury policies for funds move. So if anyone listening is interested in any of those things, definitely give us a shout. You can reach out to me at paula@range.org. But that's that for the plug. And without further ado, would love to have you introduce yourself.
Yeah, hi, I'm Carter. I'm head of business development at Phenix. Been in the space since 2017. Actually, the first 3 years I wrote and got a book published called Building Confidence in Blockchain. And then in 2020, I raised $5 million to build Shade Protocol, one of the world's first encrypted DeFi suites over
Congrats.
the Cosmos ecosystem. I did that for 3.5 years, shipped some very new novel stablecoin primitives. And then from there, joined MakerDAO and Sky as head of business development in North America, helped spread USDS to Solana and to Base, which were very successful initiatives, and then decided to jump ship over to Phenix just with the tech that they're building over here, and I'm also helping lead tokenization and stablecoin efforts with Phenix today.
Awesome. Yeah, pretty cool, and pretty cool kind of background you've had there in a couple areas of the space. Can you give me a little bit more background as well on for those maybe aren't familiar with Phenix?
Absolutely. So there's a very big problem in crypto. That problem is that as of today, I mean, north of 99% of all smart contract data is 100% transparent. This includes anything from liquidation price points to someone paying someone for payroll, for procurement, DAO treasuries, you name it. It's all 100% transparent on chain, which when crypto first started off, transparency has been kind of like its main feature and its main promise.
Yes.
But there's also downsides to this 100% transparency. We believe that in order to truly onboard hundreds of millions of users, there has to be some degree of data privacy. That's the expectation in traditional finance, and crypto is completely lacking that. And so Phenix built a chain agnostic, well, specifically focused on EVM, although it can be extended to non-EVM chains as well, where any developer can come in and add confidentiality to their smart contracts. And this unlocks a range of powerful use cases like confidential settlement and really any sort of novel situation where you want to have data private on a smart contract and you want to have some logic computing across it. All of that is kept private. And the existing, last thing I'll say here, is the existing privacy solutions also typically require you to go to some obscure L2 to get the privacy or
Yeah.
to go to an L1. But Phenix actually brings this privacy feature to public blockchains, and that is, I would say, one of the most incredible feats about it.
That's pretty cool. And I think I've heard you describe transparent DeFi essentially as kind of a war zone of bots, with the front running exploits, and everything that can happen when everything is fully transparent. How much of this belief that you have traces back to what you saw when you were building for Silk versus maybe what you saw at Sky?
Yeah, I think the thesis as a builder in the space never changed personally. Like when we were building confidential products back in the day, there was this belief that from a first principle standpoint, this is going to be inevitable at some point. The biggest transition though I've seen from 2020 to let's say 2023 to 2026, these kind of 3-year increments, is that now there is starting to be compressed and urgent demand for privacy. I think it was always kind of seen as like a nice to have or a side quest. But now when we're talking to many an institution,
Yep.
basically name any crypto institution like a BNY or a Citibank or a Fidelity. Like you can list any of these folks, and they all have privacy and confidentiality as a bullet point that their customers and clients are asking them about. They have a mandate around privacy tied to customer data on chain. Now, none of them really have a straightforward solution today, and they're more focused on growth and tokenization and getting on chain. But the fact that privacy is even something that is part of the mandate and part of the conversation is such a huge change compared to a lot of the crypto natives that have always kind of
Definitely.
said, no, like, I'm okay with this. I'm used to this world. I'm used to the transparency. It is what it is. Institutions, totally different perspective.
Oh yeah, definitely. And yeah, I think we've seen a huge kind of conversion over, I mean, I don't know, the last decade, last 5 years, but even the last year, I think. You've been, all around the conference track, talking to European, US, Asian counterparties, with, different partner conversations. What would you say is kind of the biggest difference on that front, today versus like even 12 months ago?
I think the biggest difference is that one, the institutions are actually here, but what that means is they're actually competing with each other.
Mm-hmm.
And so when they're actually competing with each other, they're saying to themselves, what is the platform edge that I have over my competitors
Mm-hmm.
outside of my existing distribution and customer set from TradFi that I'm porting over to crypto? And so I think everyone's trying to find their edge, and I think being one of the first to have confidentiality tied to, let's say you're issuing an RWA on chain, right? Like it's in the form of an ERC20. Imagine you can have an extension on top of that where you can have optional confidentiality tied to that RWA. These are the types of
Mm-hmm.
conversations that I'm having, and these are the types of things that are resonating with people because they need to be differentiated beyond just like we're yet another tokenization platform. Like there's just so much happening on chain. How do you compete?
Yeah, and I feel like, the use cases, and benefits for users is kind of, clearer, and institutions want these things. What would you say is kind of Phoenix's pitch to kind of developers to adopt this?
Yeah, for developers, honestly, we've seen a ton of traction. We have over 25 design partners and builders building on top of Phenix right now. Everyone just loves how simple it is to add in confidentiality. I think in
Mm-hmm.
2026, people don't want to fork yet another DEX, yet another Perps protocol, yet another stablecoin. I think the next cohort of builders that we're seeing, the ones that are really trying to push the envelope, once again, same as the institutions, they're trying to find an edge.
Mm-hmm.
Confidentiality unlocks a very large design space, a very large unexplored design space. And while PMF isn't necessarily fully clear, we feel
Mm-hmm.
like we have a lot of pioneering innovators, builders that are excited about the confidentiality. So we're getting inbound flow. We're getting people that go to
Always
Phoenix
good.
and they book a call with our DevRel person and they're like already building stuff. We're not having to like beg people to come and build. And the reason we're able to do that is because using the Phenix Solidity library is easy enough, intuitive enough,
Mm-hmm.
straightforward enough. We've abstracted away all of the complexities of fully homomorphic encryption, all the lattice-based mathematics, all the stuff that's really powerful. Developers don't need to know about that. They just want to know, dot encrypt, dot decrypt. Like these are the pieces of the puzzle that the primitive that they actually want to build with, and people love it.
Yeah, just making it as easy as it kind of possible to just kind of on the EVM side. That makes sense. And, so you're live on Base, Arbitrum, Ethereum, testnet, I believe.
Correct.
What does that integration funnel actually kind of look like, yeah, for the people implementing?
So the way CoFHE works, CoFHE is the kind of engine behind being able to actually run logic and compute across encrypted data, is that the Solidity smart contract on chain has data fields that have your private data that you stored on them. Let's say it's a list of, let's say you want to add a bunch of numbers together, like every address has a number tied to it, and you want to add them all up, but you don't want the whole world to know what number corresponds to which address, right? In this
Mm-hmm.
super dumb, simple use case. All of that, when you're on Etherscan and you query the smart contract, that's just sitting there in encrypted form. Like it doesn't, it's totally meaningless to you. But it's not meaningless to the off-chain coprocessor called CoFHE. And so
Mm-hmm.
CoFHE basically gets called to run the computation. It's able to actually compute, perform the computation without ever decrypting anything. And it actually is able to update the underlying state without ever like the off-chain operator has no ability to actually see what happened there, which is just an insane feature of FHE. I mean, Phenix raised $25 million plus this very novel cryptography to be able to even do that. And so when you ask, like, what does it mean to onboard to a new chain, what we're really bringing is we're bringing the CoFHE off-chain processor that can like point at this new chain and process any of the Solidity callback functions that are interacting with that want to call the coprocessor to run computation across the confidential data.
That makes sense. And that's pretty cool. Kind of congrats on figuring that out. And then I know you guys shipped, Phenix shipped Phenix 402. Can you tell me a little bit about that specifically?
Yeah, so I think the agentic payment space is seeing so much interesting innovation. And we fundamentally believe that when agents come in and want to design their own payments infrastructure and when they're making independent decisions, we do think that confidentiality could be a useful primitive for them. So the X402 work that Phenix did, we kind of did it spur of the moment. We put it out there on base. There's people that got excited about it. It isn't necessarily something that we've pushed on super hard. I think there are some builders that have been dabbling with it, and we kind of want to see what's the organic interest in using it. But TLDR, agentic commerce on chain, super interesting. Why not have confidentiality for those agents and those payments?
Okay, that makes sense. So it's kind of been, yeah, it's just one of the newer things. I guess who would be the natural first buyer of that?
Yeah, for the X402 work, I honestly, I haven't dabbled as much with the X402. I've been very
Okay.
focused on the DeFi use cases, but I'd have to imagine agents will probably want to have sub agents, right? Like picture like
Yep.
your parent and then your sub agents and your sub agents. And I think there's going to be a world where people want to protect, the agent wants to protect its DeFi strategy. It might want to protect certain pieces of information about its treasury and where it's moving that value around to various sub agents. So I think that's where there's going to be some form of confidentiality built in there. And then I also want to specify there's anonymity and confidentiality. Confidentiality is when you protect the body of the message, the content of the actual like transaction. Anonymity is where you're actually hiding sender and receiver. Phenix currently only supports confidentiality. However, we are planning on adding in anonymity. We've been kind of waiting for more regulatory clarity. We also have a very big computational upgrade called DBFV and those, we have 6 literal PhD like folks that are on the team doing the research side of things. But basically, anonymity is actually locked behind a computation and throughput problem with FHE that we've solved in research. And now it's going to be bringing that new levels of throughput to production such that we actually can bring anonymity on chain. And to circle all the way back to X402, that's where things get crazy, where you could have an agent seed a sub agent. No one knows that this agent sent funds to this other address. Like it's totally in stealth mode. And then if you have a confidential DeFi ecosystem that's also available for the agent, now you're running actual genuine strategies that can't be copycat traded. And now you have an entire agentic DeFi ecosystem where the edge that you build for yourself is actually sustained and not just copied. And that's where anonymity stuff gets very exciting.
Yeah, that was exciting, and I could feel kind of that was really interesting. That flow of how that could work. Cool. Thanks for sharing on that. And then I also want to kind of like pull back to some of your background as well and how that ties into what you're building now. So I know you built Silk originally as an over collateralized basket stablecoin after previously trying algorithmic design and post-Terra, etc. What did building a privacy preserving stablecoin actually or teach you about peg mechanics that you feel, I guess, maybe the rest of the industry is a little behind or maybe gets wrong?
Well, it's
loaded question.
It's a loaded question. Here's the way I think about it. When you issue a stablecoin, you're kind of it's a form of underwriting, right? Like it's a liability that's being issued. Someone gives you an asset. If they turn the liability back in, you need to be able to give that asset. And crypto has lost $65 billion in value since 2021 across solvency issues as well as hacks. I think it's roughly
Mm-hmm.
like 15, 16 billion on the hack side. Terra was a $40 billion collapse. That was more of a solvency problem. And as a whole, I think the industry has just had to upgrade its understanding of asset liability matching. In the earliest days of crypto, it was like, oh, see, there's this asset on the balance sheet and it's worth this much, and this is how many liabilities there are, and the assets are greater than the liabilities. It's like, okay, sure, but how volatile is the asset backing the liability? How much liquidity exists for that asset? And what happens in a compressed sprint and run on the bank? And crypto in its first, let's say 2020 to 2022, when everyone was designing stablecoins, there was a lot of experiments. I mean, people framed them as experiments, but it was really just bad finance. And I was a
Mm-hmm.
participant in that at the time. Like I was fresher to DeFi. This concept of an algorithmic stablecoin was super powerful because
Mm-hmm.
you could scale it super quickly. You didn't
Yeah.
need to pull in existing stablecoin collateral. You could just kind of like spin up a governance token. Now there's value on the governance token, and now you can issue liabilities against it. And it was not sound financial primitives. And so then the industry shifted back to over collateralized, where you have
Yeah.
different collaterals that can borrow stable, like a DAI or USDS. You can actually borrow against ETH and Bitcoin. And I think overall, over collateralized has proven that it's safe, it's secure. It is
Mm-hmm.
very capitally intensive to scale that kind of system. And so I think now
Yeah,
the
of course.
industry has landed on the middle ground, which is really yield-bearing stablecoins, where people are depositing USDC, Tether, etc. They're going to go and farm yield in DeFi or from treasuries, route it back to the staked version of the stablecoin. And I find that overall, like when you actually look at the balance sheet, it's much more sound. I think a good example of this is Reservoir. They technically had a run on the bank where the whole system completely unwinded, where all the liabilities were turned in, and actually they totally handled the bank run, and they've now rescaled back up to $100 million plus. So this is growth for the industry when we can
Yeah.
actually like wind down a stablecoin and then regrow it and prove like, see, the system is solvent. See, even in a massive bank run, the balance sheet
Mm-hmm.
does what the balance sheet does. That is huge growth for our industry. And so I guess back to the question about peg mechanics and the rest of the industry, I would say sound financial logic is what has survived and
Yeah.
persisted, and that's been the biggest change. Is just people are less and less people are building unsound financial products because everyone that's left is like, come on, we've
Yeah,
already
that's not
lost.
gonna work.
Not
Yeah,
gonna
I
work.
remember. Yeah, I remember like years ago, like pre many collapses. Yeah, I had a friend who had been a CFO, and he would look at some of these projects, and he'd be like, "I just, I just don't see how that's gonna work." And he's just like, "I'm looking at the model, it doesn't work." So, I'm glad that we've definitely been maturing past that and really making safer systems there. And then, so I want to go back to also kind of privacy and your framing around it compared to maybe institutions. So your public framing of privacy is very kind of threat model first, front running surveillance, whereas institutional framing is maybe compliance first. So yeah, attestations, selective disclosure, etc. How do you kind of bridge those two pitches in partner conversations and things like that?
Yeah, I mean, I think it starts with what the institution actually. So here's the thing with Phenix: it's very flexible. I mean, at the end of the day, it's
Mm-hmm.
a Solidity library. Anyone can do anything with that Solidity library. It's kind of a
Mm-hmm.
blank design space. So when we're talking to institutions, the conversation is mostly like, what's the problem that you're trying to solve? And the answer is
Mm-hmm.
resoundingly settlement. We're not at the stage where people are like, oh, I want to be able to make encrypted compliant dark pool on chain to try to match the dark pools that exist in TradFi's. Like that, we're pretty early on that front. Or I want
Mm-hmm.
confidential lending and borrowing, or confidential credit lines, like or confidential perps. Like the really cool use cases are still coming, but institutions realistically right now, they're just like, I want confidential settlement. It's like, cool.
Mm-hmm.
If we give you confidential settlement, what are your restraints around that? And they're like, well,
Mm-hmm.
we still want to be able to have our tokenization projects to be able to go and interact with DeFi. And it's like, okay, so now you have a problem that emerges. You want to be able to interact with Morpho and Sky and Pendle and Uniswap, but you also want confidentiality at the same time. How do we accomplish this? And the existing frameworks that have emerged from Zama and Circle and some of these other ones require you to use a wrapper, where it's like, okay, I have this token here, I deposit into some smart contract, and I get a wrapped version back. The problem that we've found with that is it's not very composable with DeFi. It's a pretty bad UX to have to like fully wrap your token to go do something and then unwrap to get back to the original thing and have it be two separate token contracts. And so something, and I suppose this is like a little bit of alpha, but what we've really seen resonate with institutions is we have a dual balanced token model that we're innovating on that allows you, it's an ERC20 with an extension, 25 lines of code added in, that anyone who issues a new token with this standard, it's you get to seamlessly go back and forth between confidentiality and not confidentiality while still having that token being able to interact with DeFi without breaking any composability, without needing a separate secondary wrapping contract. And this is resonating with institutions. So that's, when we talk with them, that's the pitch. Do you want confidentiality and do you not want to break composability? Everyone says yes, and that's leading to some like very interesting conversations. And then on the compliance side, you of course need selective disclosure. All this stuff is already built in, and there's still open questions around what do regulators actually expect. And generally, what I'm seeing is anonymity is a no-go, confidentiality is. That's generally what we see.
That makes sense. Yeah, I think that makes a ton of sense, and kind of aligns with the real world in many ways. So then another term that I think you guys have been pushing. So you guys have been pushing the term privacy stages as a framework for assessing on-chain privacy. So how do you actually use that with partners? And yeah.
Oh, this is interesting. So I think this goes back to a conversation last fall. There was kind of a open conversation in the Ethereum community about the degrees and tiers of privacy that actually exist. And I think it was like the most naive version is like a trusted execution environment because the hardware can just be cracked and then everything's broken. And then you have like your ZKs and your FHE and then some like combination of all these privacy technologies where you have like your perfect gold standard for privacy. So generally, when we talk about privacy stages in conversations with partners, we just want to help them understand the different trade-offs of the various privacy solutions. So I'll walk through kind of the three categories, in my opinion. So ZKs, zero knowledge proofs, are really good at revealing information about something without actually having to like reveal the underlying data itself. And the problem with ZKs is they're not meant to have shared state. If you want to build a smart contract that has a bunch of data on it and you want all the data to like work together and you actually have mathematical logic applied to it, ZK literally is not designed for that. To my knowledge, shared state is not a thing with ZKs. Now, it's still very good for settlement and very good for some kind of Boolean-based revealing logic, right? So there's very specific use cases for ZKs where they absolutely crush it. Good use case for it. Trusted execution environments, good for like you want a quick solution to add in privacy to something, spin up. Actually, our CEO guy Zagi was he ran the trusted execution environment division at Intel, and he made the jump to like working with Phenix. So we have and actually Guy Ziskin, the original founder, actually built Secret Network, which was a trusted execution based environment blockchain. So we have like two of some of the best experts in the world on TEs, and they've kind of said the reason they jumped over to FHE technology is because they saw how easy it was to break trusted execution environments. It's very hard to have hardware level encryption be the backrock of your privacy solution because all it takes is one operator and about $1,000 worth of gear can literally physically go into the hardware and look inside of the privacy enclave. And these types of TEs breaks are happening like about once every 6 months. There's always kind of a new exploit. So you want to have a more mathematical, pure, higher integrity privacy solution, but there's some situation where TEs are good. Like maybe it's not super valuable data, and then so you don't need as heavy of a privacy technology because the data you're protecting maybe isn't as valuable, right? And then FHE is lattice-based mathematics. You can compute across in shared state without decrypting the data. A while ago, it was considered the gold standard. Everyone was like, there's no way that you can run FHE with speed. And now it's been like 3 years, and now speed is becoming less and less of an issue. And I think it's just the strongest solution for anyone trying to make like a shared state application. You of course still get confidential settlement in the process too, but I think there's going to be composability tied to confidential smart contracts. It's going to be like one of the biggest design spaces over the course of the next 20 years of crypto. And I have to say the number 20 because it's already 2026. I remember talking about
Yep.
privacy in 2020, and it's amazing how slow adoption actually does. Adoption actually happens slower than you think for certain different attributes.
Yes. Yeah. Or I feel like sometimes it just like moves like this, and then all of a sudden it goes. Yep. So yeah, it's like the build, and then but yeah, we've been chatting about it for definitely some time. And then, one of the last questions, because we're running on time slightly. What would you say is the biggest misconception about confidential stable coins that maybe you still spend some time correcting with people? If there is a misconception.
Yeah. I think, well, there's two pieces of the puzzle. Like Phenix ourselves, we're working on a confidential stablecoin and yield-bearing stablecoin, so that's one piece. But on the other side, we're helping other people add confidentiality to their stablecoins and their RWAs. And I would say the biggest misconception is that people, when they think about integrating privacy, view it as something very intensive and difficult to do.
Okay, yeah.
And I think that actually is no longer the case. You can add in confidentiality with 25 lines of code. The encrypt, decrypt, UI, UX stuff is a couple lines of code on a job, like in JavaScript and on like an interface. So I think that's been the biggest education gap, is convincing people that privacy is no longer this massive 6-month detour to add it in. Like people, and I'm always trying to wonder, like, where does that interpretation come from? And I think it's because some of the earliest privacy projects are very, it's kind of these cryptography professionals. The lingo around it is very heavy. It's very security focused, very mathematics focused. But when it actually comes down to implementation, you don't need to understand any of that. You just need to know 25 to 35 lines of code to unlock this whole new kind of design space.
Okay, good. I'm glad we addressed that misconception, because I thought it was a bit harder as well. So you heard it here. But perfect. And then I want to make sure I also give you time to talk about anything that maybe we didn't go over today as well.
No, I mean, I think it was a really good set of questions. I'll just say that Phenix is planning on revealing its confidential stablecoin and yield-bearing stablecoin in the coming months, so definitely stay tuned for that. We think the industry, to my knowledge, there does not exist today any confidential yield-bearing stablecoin. There are some confidential stablecoins, but they usually exist on L2s, or people's idea of confidentiality is interacting with a mixer. That's definitely not my idea of confidentiality. So we are going to be bringing one of the world's first confidential stablecoins to a variety of public blockchains, and I think the use cases are going to be super interesting. So just be sure to follow Phenix, be sure to follow along. There'll be more information that comes out soon enough on that front.
Awesome. And where should people connect with you guys?
Yeah, you can follow us on Twitter here, which is me just pulling up the tag really quick. 1 second. Okay, so you can follow us at FHENIX at
There we
Phenix.
go.
And then also check our website, phenix.io, for the full rundown. We also have a live demos app where there's like, the team has made like 10 different demos you can mess around with, kind of highlighting the power of confidentiality on smart contracts. So be sure to check that out too.
Awesome. Well, then thank you. And thank you so much for, sharing everything. It was really interesting. And I don't think I realized it was that easy to put that in. So I think it's a very natural progression for the space. 6 years, it's coming. So excited to see how things continue to evolve over the next years. And thank you again for taking the time.
Thank you for being a wonderful host.
Cool. Awesome. Have a great day. Bye.